What is blockchain? In plain words, it can be described as a decentralized digital record of transactions that records information permanently with verification. Here, there are three highlighted keywords. They correspond to three key features of a blockchain. First, decentralization. Second, immutability. Third, consensus. So let's talk about these three key features. First, blockchain stores data in a very different way than traditional database. In blockchains, data is stored in so-called blocks. You can imagine a block as a package of information. Let me use an example to conceptually show you how it works. So imagine you work for a bank and your job is to keep all the paper transaction logs. To do that, you open the box and wait for transactions. Once the transaction happens, you put the log into this box. Once the box is full, you close this box and mark this box 1 in black. Then you open the second box to store new transaction logs. Once the second box is full, you close it and mark this box 2 in black. But now you also leave another mark 1 in red, so you know this box is created after box 1. Now you open a third box for new logs. Once it is full, you mark 2 marks. You mark a 3 in black and another 2 in red. Then you keep doing the same. So in the end, every box except the first one has 2 labels. Its own label in black and a record of its previous box in red. This is essentially a blockchain. The boxes are the blocks and they are chained with the labels. So basically, you can see blockchain as a chain of blocks connected through labeling. What is special about this way of storing information? The most important feature here is once an information is written into blockchain, it cannot be revised or removed. And this is something called immutability. In other words, the data in blockchain cannot be changed. Decentralization is another difference between traditional database and blockchain. Broadly speaking, a blockchain is decentralized in terms of information storage and governance. Decentralized storage means that data is stored in multiple computers or so-called nodes in a network. In other words, every node in the network has a full copy of the entire blockchain. This is the opposite of a centralized storage, where data is stored in a single location in the network. Examples of decentralized storage include cloud storage such as Dropbox and Microsoft OneDrive. On the other hand, MS Office and Windows in your PC are examples of centralized storage. Decentralized governance means that there is no single entity with full control over the data. On the other hand, centralized governance means that there is an entity who has full control on the data. Examples of decentralized governance include open source applications such as Linux operating systems and Mozilla's Firefox web browser. Centralized governance is probably the dominant form of governance. For example, our Facebook and LinkedIn data is controlled and maintained by those companies. It is probably not hard to realize that most applications around us are centralized. So why does blockchain choose to work under a decentralized system? Well, decentralized system overcomes some major problems in a centralized system. First, bad actors. The centralized authority can inappropriately restrict access to data, modify data, or use data without data owner's consent. For example, Wells Fargo was sued for opening roughly 1.5 million bank accounts and applying for more than 500,000 credit cards that may not have been authorized by their to customers. Another example, in June 2015, Greeks are only allowed to withdraw 60 euros a day due to the country's financial crisis. Just give you another one example. Many social media profits from user data without users' acknowledgement. In other words, users do not have the control over their own data. The second problem is single point of failure. If the central server crashes or gets hacked, then the system will cease to function. This has led to many high-profile incidents. For example, Marriott discovered in 2019 that 25 million passport numbers has been stolen. In a series of breaches revealed in 2012, LinkedIn leaked out more than 100 million emails and passwords. So security is the biggest issue in a centralized system. On the other hand, a decentralized blockchain overcomes these issues. For example, data is stored in multiple nodes, so hackers will find it harder to tamper with the data. Also, if some of the nodes leave the network or are shut down, the entire blockchain can continue to work without interruption. In other words, decentralization is a key reason why blockchains are safe and trustworthy. We mentioned that blockchain is a decentralized system where every node owns a copy of the entire blockchain. But then that leads to an important question. How do you make sure every node updates their blockchain at the same time? Who decides what to write into a new block? This comes back to the Byzantine generals problem we mentioned earlier. The spirit of the problem is that everyone can say anything in the network. In that case, how can we trust the information we receive while keeping everyone in the network synchronized? Consensus protocols are the key to answer that question. Consensus protocols are a set of rules that specify how information will be verified before writing into the blockchain. The most well-known one is called proof of work. It is a protocol used by Bitcoin. Proof of work has its strength, but it also has weakness too. So other alternative consensus protocols such as proof of stake are also emerging. So how does a consensus protocol work? Let me use proof of work as an example. There are many details that I will skip here. My goal is to show the key features and ideas. So let's say there are 3 nodes in this blockchain network. As we mentioned in the decentralization, every node has an identical copy of the blockchain. Proof of work works like this. First, every node will work on a new block on their own. They will collect information such as transaction logs that is broadcasted to the network. Every block has a size limit. So that means there's only a certain amount of information that can be put into a new block. The first node that finishes its new block will send this newly created block to other nodes in the network. Other nodes will verify if this new block is correct. If majority of the nodes find that this new block is correct, then a consensus is reached, and this new block will be added to the blockchain of every node. At this moment, the creator of this block will also receive a reward. This is how blockchain keeps all the copies of blockchain in the network synchronized. There are a few features here. First, there's incentive for every node to participate in the network. The first one to finish a new block will receive the reward if the newly created block is verified. Second, the consensus formation is a democratic process. That is, a new block is added to a blockchain once the majority of the nodes agree so. So now let's summarize what blockchain is. If you remove all the fancy words and take it to the core, in a nutshell, blockchain simply offers a new way of data storage. And this new way of data storage comes with 3 key features. First, Immutability, which means that you can only add new information, but you cannot revise or remove any existing information in the blockchain. Second, decentralization. That means data is stored in multiple places with shared governance. As a result, there is no single point of failure. Third, consensus. This is the key mechanism to enable data synchronization. Well, all these three are good technical features, but in an even higher level, what is blockchain's core value proposition? Here's the answer: trust. Maybe we cannot trust everyone in the internet, but we can trust that the information in the blockchain has not been tampered with. Bitcoin is the first commercial application of blockchain. It is exactly because of this level of security and trust that allows Bitcoin to work for more than 10 years without a central bank.